Hi, in this screencast I'm going to walk you through the problems in Project 2 and give you some hints. Project 2 is about writing straight line Python programs. So here's the PDF for the project. You can find a link to this PDF on the assignments page of the course website. On that page you will also find a link to the zip file for the project, and when you download and extract the zip file in your computer, you're going to see a folder such as this with these files in it. Okay, now some of the files in there are the starter files for the project, and then you have runtest.py that you should be using to make sure that your programs meet the input and output specifications, and then there is report.txt that should serve you as a template when you write your report for the project. Okay, so now let's walk through each of the problems in the project. So the first problem is called WhenShell. Here you're supposed to write a program called WhenShell.py that takes two command line arguments as floats. Let's call them T and V. Now these arguments are going to represent the temperature in Fahrenheit and the wind speed in miles per hour. Now what your program is supposed to do is compute and print the wind chill. Okay, and you do that simply by using this formula here. So this is the formula that calculates the wind chill given the temperature and the wind speed. Okay. Now, when you write your program, just keep in mind that command line arguments are strings. So here you want to treat them as floats, so you first want to convert them using the conversion functions before you assign them to these variables, okay, T and B. Alright, and then also keep in mind that if you want to exponentiate something in Python, so for example, that is, if you want to compute something like v to the power 0.16, you can simply use the exponentiation operator, which is the star operator. Okay. All right. Now, once you have your program written up, you should test it by running this command here on the terminal. And so here the value of t is 32 and the value of v is 15, and the program prints the corresponding wind chill value as that. Okay, so that's problem one. Let's go to the next problem. So here you're supposed to write a program called bmi.py that takes two floats as command line arguments. Let's call them W and H. These represent the weight and height of an individual in kilograms and meters respectively, and the program is supposed to compute and print the body mass index for that individual, which is simply given by the weight of the individual divided by the square of the height of the individual. Okay, so the BMI is simply W divided by H squared. Okay, so that's what the program is supposed to compute and print. So once you have your program written up, you run it using this command on the terminal. So for example, if the weight is 75 kgs and if the height is 1.83 meters, the program is supposed to print this value for the BMI. Okay, so that's problem 2, a very straightforward problem. The next problem is where you're supposed to write a program called polar.py that takes two floats x and y as command line arguments. Okay, so these numbers are going to represent the Cartesian coordinates of a point, and what the program is supposed to do is print the polar representation of the point. Okay, so what is given to the program is the Cartesian representation of a point, such as that one there. So the inputs are x and y. So this is the xy plane. There is the origin, and what the program needs to do is compute the polar representation of the point. So the polar representation is given by two numbers, r, which is the distance of the point from the origin. So this is a right angle there, and theta, which is simply the angle that the point makes with the positive x-axis. Okay, so this length here, of course, is x, and this length here is y. And the way you calculate r and theta is using those expressions in the PDF. So r is simply, by Pythagoras rule, it is square root of x squared plus y squared, and theta is simply the tan inverse of y divided by x. Okay, so that's that. Now just keep in mind that um, uh, when you need to use the trigonometric functions, you can simply use the math library. So there is a function called atan or something like that that you could use for computing the inverse tangent of a number. Okay. And then here, when you want to calculate the square root of a number, I mean, you can certainly use math.squirt, but it is not necessary. You can say a better way to do it is simply using the exponentiation operator, right? So I'll let you figure out how. Alright, so once you have your program written up, you can run it as follows on the command line. So here x is 1 and y is 1. The program is supposed to come back with these numbers for r. So that is simply square root of 2, right? Since that's the distance of this point from the origin. And then theta here is 0.78 something 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 in radians. Okay. Alright, the next problem is about writing a program called ordercheck.py that takes 3 floating point numbers x, y, z as command line arguments. Okay, and then the program is supposed to print either true or false. It's supposed to print true if the given numbers are in strictly ascending order, meaning x is less than y and y is less than z, or in strictly descending order, meaning x is greater than y and y is greater than z. So in those cases, the program is supposed to print it true, but if the input numbers are not in any order, the program is supposed to print false. Okay. So here you should not be using an if statement to write your program. In fact, you're not allowed to use the if statement here. All that you need to do is come up with a Boolean expression that captures this idea. Okay, and once you have that expression, you simply write it out using stdio.writeln function. Right? All right, so once you have your program done, you can test it by running these commands on the terminal. So here the inputs are 245 for xyz, and the program comes back with true because they are in ascending order. Here the program comes back with false because the numbers are not in ascending or descending order. Okay, whereas here the program is supposed to print it true because these numbers are in descending order, and so on and so forth. Okay, so that's problem 4. In the next problem, you're supposed to write a program called dayofweek.py that takes 3 integers as command line arguments. Let's call these integers m, d, and y. So these are going to represent the month, day, and year. And then the program is supposed to write the day of the week that corresponds to that given date. Okay, and the day of the week is going to be a number between 0 and 6. All right, and we're going to call that number capital D, and D is very easily calculated using these formulae. All right, you just have to carefully implement these expressions, and then at the end, once you have calculated these the values for these variables, you plug them into an expression that calculates the value for capital D, and capital D, if you do things correctly, is going to take on a value between 0 and 6. Okay, so it's a very easy problem. So once you have written it up, you should test it by running this command on the terminal. So here m is 3 for March, 14, that's the value for D, and then y is 1879, and the program is supposed to print 5 in this case because this was a Friday. Okay. Alright, so that's problem 5. Let's move on to the next problem, which is called Mercator Projection. Okay, the Mercator Projection is simply an idea, a projection that maps latitude phi and longitude lambda to rectangular coordinates x, y. Okay, so for example, you might be interested in a particular point on the surface of the Earth. Okay, so these are the longitude lines, and these are the latitudes. So you might be interested in some the Mercator projection of some point here. Okay, so this guy is given by two numbers, the latitude phi and the longitude lambda, and what you want to do is find its Mercator projection. You mean and by that we mean you want to find the xy values corresponding to that point on a flat surface. Okay, so some point here, x1. Okay, and the way you calculate x and y are by using the formulae that are given to you here. So x is simply lambda minus lambda naught, where lambda naught is the longitude of the point that will appear in the center of the map. Okay, so you get to pick lambda naught, and that so lambda naught could be any longitude that you're interested in, and those points, the points on that longitude, will be smack in the middle of your map. Okay, so that's lambda naught. And so x and y are simply calculated as lambda minus lambda naught and half times natural log of this expression here. Okay, so now natural log can be very easily calculated using a function from the math library, and you can also calculate the sine of an angle quite easily using the math library. Okay, so just remember though that the trigonometric functions such as sine, cosine, and tan, they expect the input to be in radians. Okay, but the inputs to the program are in degrees, so you need to convert them into radians, and you can do that very easily using the math.radians function. Right now, so once you implement your program, you can test it by running this command on the terminal. Okay, so here for example, lambda naught is 0, and then this is the longitude and latitude of Boston. Okay, and the program comes back with this number. It's supposed to print this this pair of numbers. So this is x, this is y, and that represents the Mercator projection of this point here, expressed in terms of phi and lambda, that is the latitude and longitude, and also this value lambda naught. Okay, so it's a pretty straightforward program. The next problem is called great circle. So here you're supposed to write a program called greatcircle.py that takes 4 floats as command line arguments. Let's call them x1, y1, x2, y2, and these are going to represent the latitude and longitude in degrees of 2 points on Earth. Okay, and what the program is supposed to do is calculate what is called the great circle distance in kilometers between the 2 points. Okay, this is essentially the distance that a plane would travel in going from one point to the other. Okay, and the great circle distance can be very easily calculated using this formula. So all that you have to do is implement this formula in your program. Okay, so it just involves a bunch of trigonometric function calls. And again, keep in mind that when you call sine and cosine, you have to make sure that the input is in radians, and you can convert degrees to radians using math.radians. And then when you perform this multiplication here, the value returned by the inverse cosine and 111, you need to make sure that the value returned by inverse cosine or arc cosine is first converted into degrees before you carry out the multiplication. Okay, because the inverse trigonometric functions, they return a degree. All right, they take a number as an input, they return a degree, and and it's returned in radians. So here you first need to convert it into degrees before you carry out this multiplication. Right, so once you have your program written up, you can test it by running this command on the terminal. So here, for example, our inputs are these 4 points representing the latitude and longitude of Paris and San Francisco, and the program is supposed to print a number that is this value. Okay, so this is essentially the great circle distance between Paris and San Francisco. It's about 9,000 kilometers. Right. Okay, so moving on, problem 8 is about writing a program called 3sort.py that takes three integers as command line arguments, and it is simply supposed to write them in ascending order separated by spaces. Okay, so if your inputs are 2, 1, and 3, the program is supposed to put them in order, that is, write them as 1, 2, and 3 separated by spaces. Okay, so now in this program you're not supposed to use the if statement at all. Instead, you should simply be using the min and the max function to get the job done. Okay, so there's a very nice way of doing it, so I'll let you guys have fun with it. Okay, so you're not supposed to use the conditional statement at all, so no if statements for this problem, okay, or for any of the problems in this project. So you're not supposed to use control flow statements at all. All right. Okay, so once you have your program written, you can test it. So you can run this command, for example, with the inputs 2, 3, and 1, and the program is supposed to put the numbers in order and write it as 1, 2, and 3. Okay. All right. The next problem is called random integer. So here you're supposed to write a program called randomint.py that takes two integers a and b from the command line, and it's supposed to write a random integer between a and b. Okay, but keep in mind that the random number that is written is greater than or equal to a, and it is strictly less than b. Okay, so the right endpoint is exclusive. So there are a couple of ways of doing this. You can either use the random function, in which case you'll have to scale your numbers suitably to get it in the required range, or you can simply use a random.randrange. Okay, and once you have written your program, you can test it as follows by running this command on the terminal. And here a is 10 and b is 20. The program prints 13 in this case. Okay. The next time you run it, you might get a different number, but it has to be in the range a through b, where a is inclusive and b is exclusive. Okay. It's a pretty straightforward problem. All right, and then the last problem is called 3dice. So here you're supposed to write a program called 3dice.py that writes the sum of three random integers between 1 and 6, such as what you might get when you roll 3 dice. All right, now once you implement problem 9, you can simply carry over that idea into problem 10. Okay, so here you're essentially using the same idea with suitable values for a and b. All right, and then instead of doing it once, you do it 3 times to produce 3 random integers in this range, and you simply need to sum them up and print the resulting value. Okay, so when you you test the program by running this command on the terminal, and the program ought to come back with a random integer between 1 and 6. Okay, where both 1 and 6 are included. So the random integer is greater than or equal to 1, and it is less than or equal to 6. Okay, so that's that. Now once you're done with all the problems, these are the files that you need to submit. Okay, so 10 .py files, and then remember that you also have to turn in a report. Okay, so now for the report, you should be using the template that is given. So here again, make sure that you fill in all the sections. I need to know how long it took you to work on the project. I hope it didn't take you too long, because it's a pretty straightforward project. And then you need to tell me how you approached each problem in the project, so in a few sentences. And then in here, which is a very important section, I need to know who you received help from. Okay, and then finally, if you learned something from the project, or you enjoyed doing it, please tell me about it. Okay. So that's that, and as I mentioned in class, this is one of the easiest projects, okay, in this course. So I hope it doesn't take you too long to work on it, and I hope that you enjoy doing it and that you learn a lot from it. Okay, and finally, before we wrap up, just make sure that you test your programs for to make sure that they meet the input and output specifications, and you can do that by simply running runtest.py. Okay, so you can either say Python run test without any argument, in which case all the problems are tested, or you can test individual problems by listing their numbers. So for example 1, 5 and 9. Okay, all right. So that's that. And then make sure that your programs meet the style requirements, and you can check your programs for style by running pep8 on the program name. So you can say pep8 and then 3dice.py. Okay, so it'll test the program for style. And finally, just make sure that your reports don't exceed 400 lines, so they shouldn't be too long. And then make sure they don't have spelling mistakes, and also make sure that the lines don't run over 80 characters. All right. Okay, so that's all that I had to say in this screencast, and all the best on the project. Thank you.